Hi, my name is Dmytro Firsov. I'm from Ukraine and working as a software engineer in EPAM systems. I joined the Zephyr community about a year ago, and now I am working on adding Xen-related feature support to the Zephyr project. And today I'm here to talk about virtualization with Zephyr and Xen for embedded safety systems. Here you can see today's talk agenda. First, I want to say a few words about virtualization in general. Virtualization is a process that allows you to create and run virtual instances of computer systems, virtual machines, on the same hardware simultaneously. It is commonly used nowadays because it allows you to make a lot of cool things like environment isolation, simultaneous run of different operating systems, system resources fragmentation, and many, many more. To perform virtualization, special software is needed. It is called hypervisor. Hypervisors are divided into two generic types based on the environment they are needed to work. The first one is bare metal hypervisors. They are usually started by bootloaders and run directly on hardware. Second one is hosted hypervisors. They looks like a usual process in operating systems and need operating systems to be started. Today's talk will be about Xen Hypervisor. It is type 1 or bare metal hypervisor. Xen is actively developed and supports running on x86 and ARM platforms. And I will be talking about the latter. It gets started by a bootloader, perform memory and CPU initialization and management. VM in the virtual machines in Xen hypervisors are called domains, and one of them is privileged. It is called domain 0 or DOM0. Let's look at the classic Xen domain model. As you can see, Xen is running directly on hardware and can trap any actions from all domains. Also, you can see one instance of privileged domains which contains hardware drivers. DOM0 has access to real peripherals. And one or more instances of unprivileged domains, or DOM-use. Usually, DOM0 performs control functions and deal with domain configuration, management, communication. Also, it needs to work with hardware through the hardware drivers and start par-virtualized backend drivers. Backend drivers are needed to give interface for unprivileged domains that contains front-end drivers. So in this case, DOM0 works both as control and hardware domain, but it can be changed with thin DOM0 concept. Here you can see the thin DOM0 concept. For thin DOM0 is concept for Xen domain model where DOM0 works only as a control domain and doesn't deal with hardware. Privileged domain offloads hardware access to one or more hardware domains. These hardware domains contains real drivers, real hardware drivers, and also such domains starts the par-virtualized backend drivers and serve hardware requests from other domains. Hardware or driver domain is usually called domain D or DOM-D. Such disaggregation allows to remove driver code from control domain, simplify the system structure, and increase overall system safety. Also, this approach gives the possibility to use much simpler than Linux operating systems for thin domain 0. We've been looking for a Linux alternative in DOM0 for functional safety use cases. And we think that Zephyr RTOS it looks like the best candidate for these purposes because it is free open source software that is actively developed. It is also a part of Linux Foundation, Xen Project also too. and it is targeting functional safety use cases. The Xen domain zero concept allows us to minimize changes to Zephyr that are needed to use it as a control domain. Some boot steps can be performed by external bootloaders inside the created domain, and this will require less actions in the Zephyr control domain. But it still requires to implement some set of software tools that will allow Zephyr to create, destroy, configure new domains, and establish communication between them. This can be done by developing a special Zephyr application. So let's look at the possible concept for Zephyr Xen Dom0 approach. Steps that lead to Dom0 boot do not need to be changed compared to system with Linux-based Dom0. Also, the Zephyr image can be easily started directly by Xen without any external bootloaders. You need just to pass its image to hypervisor. After boot, Zephyr Dom0 should have an application that will allow you to create the external domain. After creation, such domain should be configured with some parameters and get the memory map. Also, hardware domains should have a possibility to access the real hardware. For such domains, we need to set up a peripheral fairing that consists of device IOM regions mapping, giving access to IRQ and IRQ mapping, and setting up the IOMMUs, because unprivileged domains in Xen are not mapped one-to-one in address space. After this, we need to load and start domain software. To boot external domains, Zephyr should have an image that will make some steps required for booting newly created domain. It marks as IPL on this scheme and should have a possibility to load and boot external domain images from some storage. It's binaries, device tree, etc. To minimize a footprint of such IPL, we can augment it with per domain bootloader, for example, uboot, as a next step. Further boot steps will be the same with the Xen Dom0 that you use in Linux, and all these steps will be performed inside the created domain. After domain boot, we need to access the domain console and establish PV drivers backend to front-end communication. Domain communication in Xen is set up via Xen service called XenBus. So we also need to implement the console and XenBus services in Zephyr Xen Dom0. Zephyr Xen Dom0 approach will bring a lot of advantages compared to classic Linux Dom0. First, this will improve the system boot time because Zephyr becomes ready to create new domains much faster than Linux. Second, Zephyr requires smaller amount of system resources, so it will reduce their consumption and will allows us to give more for other domains. Third, Zephyr is much simpler than Linux. This will reduce overall system complexity. And fourth, potentially enable functional safety scenarios for virtualized systems. Xen community is actively working to allow certifying Xen for FOSS, partnering with other Linux Foundation projects. So now we can talk about the things that we have already been done for this in Zephyr upstream. Initial Xen support was introduced by my EPAM colleague Volodymyr Babchuk more than a year ago. He added a special Xen VM board that is supposed to work as ARM64 Xen guest. It didn't contain any PV drivers and used emulated hardware as a timer, geek, and PL11 UART for work. That was cool, but it was not enough. We wanted to make Zephyr fully power virtualized, so we started to develop Xen PV drivers. I implemented some set of base Xen features. It's hypercold wrappers. It is the interface that allows to Zephyr to interact with the hypervisor via special assembler instructions. The Enlighten page mapping. Enlighten is a special memory page that assigned to all created domains, and it contains Xen system information. And also the event channels. It's a Xen primitive for inter-domain interactions via events. These changes were submitted to the Zephyr repo and successfully merged last year. The next step was implementation of first PV driver for Xen PV console. It should be used instead of PL11 UART emulated hardware. Xen Hypervisor console was taken to the Zephyr mainline 2. It has two versions, ring buffer based. It works for Zephyr that runs as the unprivileged domain, the classic Xen console, and console AO hypercall based. It is the default console for Dmytro domains. Some of Xen features are now on review, and one of them is event channel driver improvement, which allows user to allocate and bind inter-domain event channels. Because previously this driver supported only Xen predefined channels. The second big feature is Xen Grantable driver. Xen Grantables is an interface for memory pages sharing between the domains. The Zephyr implementation will support page allocation, granting access to them, and mapping foreign frames to Zephyr address space. These pull requests are available by links in the presentation. And also one big feature that is planned to be submitted is ZenBus driver. ZenBus is a complex Xen interface that used for a lot of purposes. For example, receiving information about the domain, front-end, back-end drivers bindings, page reference sharing for future mapping, parameters exchange, and many, many more. It is crucial for configuration and establishing a connection between PV, backend, and front-end drivers. The more detailed information about this feature you can find in board documentation in the Zephyr repository. It was challenging to develop Xen support for Zephyr and boot it as Xen control domain. Here are some problems that we faced during the development. The first one is Zephyr licensing issue due to Apache licensing. A lot of ready-to-port code of Xen drivers is created under incompatible GPL license. Also, the MIT license code requires a TSC approval for every submit. The second one problem is Zephyr static configuration. Due to static configuration in Zephyr, some issues may be caused by Xen in runtime. Usually such problems are fixed by changing the device trees that is passed to domain, but Zephyr doesn't use it at runtime. For example, domain memory map for Dmytro may differs from boot to boot when you change its configuration. Xen may place the Dmytro in other place than a previous time because Dmytro is mapped one-to-one in address space. It was real address space of the board because it has access to all hardware. But for same configuration, for same domain configuration, this map doesn't change usually, so Zephyr can boot successfully and doesn't need to be recompiled for other address. I hope that it will be possible to fix this in future and reconfigure Zephyr in runtime, for example, by passing some parameters and parsing them in runtime after boot. Also, one of the problem is a slow review of Xen-related pull requests. Reviewers are not ready to approve changes that are related to Xen, and some of them may be unreviewed for a month. I hope this situation will be changed when interest to using Zephyr as Xen guest will rise. And the last thing I want to talk today is the Zephyr Dmytro development status. It is currently being developed by me on Renesas H3 hardware. I used a modified version of Zephyr RTOS as a control domains. It includes also the Zephyr Xen utils application for domain management, and you boot for Xen and you boot with Xen support as a bootloader for hardware domain. All source repositories are available by the links in the presentation. Now I want you to look at the diagram and check the Dmytro Zephyr structure. Zephyr and Xen images are loaded by initial bootloaders. Then initial bootloaders gives control to Xen. Then perform memory and CPU initialization and starts the control domain. It is Zephyr. A lot of changes were made to be able to perform memory and domain management from Zephyr Dmytro kernel. It contains various drivers, the Xen DOM-CTL interface. It is special hypercalls that is needed for domain configuration, memory helpers, and many more. Also, this required Zephyr application that will perform domain creation and perform generic operations that is needed for this. It was separated from Zephyr kernel and contains in a project that is called Xen utils. It allows to change domain configuration inside the config structure in code and start different operating system as a guest domains. I successfully booted unprivileged instances of another Zephyr and you boot with Xen utils. In this domain, we use hardware domain, and this hardware domain runs Linux. To boot Linux, it was decided to use U-boot as an intermediate step. This allows us to minimize changes that are needed to Zephyr. U-boot image is located inside the Zephyr binary as a separate section for now. It starts and takes control over the shared peripherals with this domain. U-boot uses one of the boards UART for logging. This will be replaced by classic PV console when we will implement the console daemon for Zephyr Dmytro. And also it uses the Ethernet device that is used for Linux image loading. The image and device tree via network. To use Renesas drivers in Xen U-boot, some changes were needed. They were related to kconfig, so I decided to separate this case for new board devconfig. At the time of this recording, Linux boot in DOMD is not ready, but I think it will be available soon. So here you can see the brief result of this development. The next development goals are, as I said, the Linux boot, upstreaming of the ZenBus driver, and implementation of ZenBus and console daemons for Zephyr control domain. That is all I wanted to tell you about. Thank you for attention and feel free to ask any questions.
Is he on the? Is he on the Zoom? Yeah. So oh, okay. So the Zoom would come over the speaker here too, though, right? Yeah. Okay. Yeah. I understand. Okay. Well, that's that's the state of that. So one of the things I picked out of this, though, just to help their efforts, is he commented on the fact that there's slow review cycles on this. I don't know if the people in this room are interested in this topic. I've actually did a deep dive on Xen about 2 years back for other reasons. So it seems like he could use some help on the reviews. Yeah. Well, I don't know, though. It depends on where they're at. Yeah, that's true. Well, excuse me?
Oh, I was just saying, Carlo, the ARM64 maintainer, has done a little bit of Xen work, so I'm almost volunteering him here.
Okay. Okay. So, and I think I'll reach out to him as well, that if he's got some things that he needs TSC attention, then there's a process to do that. I don't know if he's done it yet. Maybe he has, but we'll help facilitate that on this, because I know that there's other virtualization projects ongoing to take Zephyr and drop it into a virtualized environment. This Xen is a kind of a from a virtualization perspective, is an environment where both sides know that they're running it. Well, obviously the host side knows, but the thing that's running in there also knows, because it's going to have specialized drivers to do the communication across the boundaries and stuff. So I was impressed when I first saw the first bit that was dropped in. And I'm glad to see that he's still working on it.